Now let me show you one presentation. I would like to share with you how to understand some things relating to astronomy and how to solve some sample problems, text problems. So let me find it. Distances in astronomy. Hope you see my cursor. If we are speaking about distances in astronomy, definitely the distances are very big. That's why we are using some prefixes which denote something which is bigger, larger, like, for example, deca, symbol DA, which means 10 times greater, hecto, symbol H, 100 times greater, kilo, symbol K, 1000 greater, mega, symbol M, 1 million greater, giga, 1 billion, and so on, tera, peta, exa. There are some prefixes which denote something which is smaller, but we are not especially interested in it because, as we said, the distances in astronomy are very big. Quantities and units. In order to describe something, also in astronomy, we are using some basic main quantities like length, mass, time, current intensity, temperature, amount of substance, luminosity. And each of these quantities has its own unit. Unit, it means the way we measure that quantity. For example, the length is measured in meters. Mass in kilograms, time in seconds, current intensity, it's not where we I'm sorry, I can't see now, something happened. Let me return and start over again. Yes. So we stopped at current intensity, which is not within our interest. If we are speaking about astronomy, temperature in kelvins, amount of substance in mole, also not too much within our interest. Luminosity is expressed in candle. These are quantities and units in so-called Sistema International, international system, which is used all over the world. In particular, in astronomy, we are using specific units like astronomical unit, AU, which denotes the mean distance between Earth and the Sun. And the mean distance is 1.5 times 10 to 9th meter. Light year, a symbol LY, a distance covered by light in vacuum within 1 year, within 1 second, because the speed of light is very big. 3 times 10 to 8 meters per second. Such a huge distance is covered within 1 second. if you would like to know what distance is covered by 1 year to get light year, you have to multiply the 3 times 10 to 8 meters times 60 at first, because 1 minute has 60 seconds. Then again by 60, because 1 hour is contains 60 minutes. Then 24 hours for 1 day. Then 365 days for 1 year. So the distance is huge. And here is how can we find it in meters or astronomical units. Another important unit in astronomy is parsec, symbol PC. It's a distance from which one astronomical unit is observed at the angle of 1 second. In general, 1 parsec is a bit greater than 1 light year, because as you see here, 1 parsec is 10 to 16 meters, and one light year is 10 to 15 meters. Okay. Now a picture which presents a number of planets in our solar system. Here the yellow ball is our sun, and the planets. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Pluto is not visible, it's far away. The same solar system, but from a different perspective. The glow ball is our sun, surrounded by our planets, which circulate around the sun. The comparison, take a look at the upper left corner. The yellow sun, as you see here, is multiple times larger than Earth, which is represented by this black dot. Over here we have some other stars, but those stars are not in the scale if you would like to compare with the sun. That's why we have one more picture over here where our sun is here. It's a very small yellow dot as compared to some other stars like Arctur, Rigel, Antares. So as you see here, the stars can be much bigger than our sun. Our galaxy, Milky Way, which is composed of number of stars, planets, cosmic objects, interstellar gas, comets, asteroids, and this type of stuff. And our galaxy has a form, has a spiral form. This is a typical form for a galaxy, but not all. Some other galaxies, if you would like to compare distances from us and their diameters, for example, here, this galaxy is 55 million light years away and has a diameter of 95,000 light years. And some problems to solve. Let's do one of them. The first one, Venus orbits 0.72 astronomical unit from the Sun. What is the distance in kilometers? In order to solve it, we need to compose a proportion. We are starting the first row from what we know, And we know that 1 astronomical unit is equal to 1.5 times 10 to 6 kilometers. Below, we are writing what we know from the text. We know we have 0.72 astronomical unit. We place it right under 1 astronomical unit over here. This corresponds with our unknown x. We are looking for x. So this is our proportion. We cross multiply 1 times x equals 1.5 times 10 to 6 times 0.72, which is written down here. 1 times x is x, and here if you multiply, you receive this number. And this is our solution. I recommend to solve by yourself problem number 2, which is already solved, but do it yourself. And problem number 3, which is not solved, and treat it, please, as your task in order to find out whether or not you understand how to solve some astronomical text problems. Okay, I would like to thank you for being in my class, and I would like to emphasize to contact me whenever a need arises. And if you come up, if you encounter with some problems, concerns, or you can't understand something, you are welcome to contact me. So once more, thank you, and I wish you good luck in our class.